Hey, you guys, I've got the greatest new invention. You take a piece of material, cut it into a round shape, then put a perpendicular thing through the middle, and you can. Oh, wait, somebody already did this? Oh, yeah, that's right. If you're like me, every time you do an IoT design with sensors and Bluetooth, you feel like you're reinventing the wheel. We spend so much time doing all the same stuff everybody else has to do before we start the real work that makes our application awesome. Maybe we should do something about that, don't you think? Hi, I'm Amelia Dalton, host of Chalk Talk. Today I'm talking with Francesco Doddo of STMicroelectronics about the BlueNRG-2 IoT Sensors Development Kit, which can get us way down the road on our sensor-based IoT design without spending weeks reinventing, well, you know. And before we get started, don't forget to click that link. There you can find even more information about the BlueNRG-2 IoT Sensors Development Kit from ST Microelectronics.
Thank you. Thanks a lot.
Okay, so we are here to talk about BlueNRG tile. But first, can you tell me what is all of this all about?
Absolutely. So that's a little board that we put together a few months ago with the intent actually to address a lot of IoT applications and specifically application in the industrial space. So we wanted actually to have a single unit with all the sensors and connectivity and processing power to enable actually battery operated applications to be connected with the cloud. And so that's pretty much what we want to achieve with the BlueNRG tile.
Okay, so in short, what can you do with the BlueNRG tile?
So really, in a summary, there are three things that we want to achieve. Implement motion algorithms within the BlueNRG tile, being able to transmit voice over Bluetooth Low Energy, and implement wireless network with the Bluetooth Low Energy mesh in the board.
Cool. Can you show me an example?
Absolutely. So I have in front of me a little board over here, right? I'm going to plug the battery in the board. And the first thing that we're going to do, we're going to connect to an app that is available both on Android and iOS. And once we connect, the first thing that we're going to be able to see in the board is really a bunch of sensors that you can actually read. So we're monitoring the data that are coming from the sensors. And all this data can be logged in the app and sent offline through an email, for example, to your favorite email address. But you can also monitor the same data using a USB connection and connecting basically the board to your computer. So you have two ways actually to sense the data and log the data.
So what about remote toggling?
That's an important feature. It seems basic, but in reality, this gives you the possibility to control what is happening on the board. An example is that you can toggle an LED on the board just using that icon that you see here on the smartphone, where you can turn it off and turn it on, really toggle the LED. So this allows you actually to do even more when you put your hands really in the code and you can control remotely the sensors within the board.
So can you use the board to detect different types of events?
Absolutely. That's a great question because it really highlights the low power consumption of the boards. So all the sensors that are available within the BlueNRG tile, they offer embedded capability to detect events. So that means basically that you can let the main microcontroller, the main Bluetooth Low Energy SoC to sleep while all the sensors are processing data. And if a feature or an event is detected, they actually notify and wake up the Bluetooth Low Energy microcontroller and then notify the app. As an example, you see here in this picture a tap. So the inertial sensors can automatically detect the tap on the board if you push with your finger the board. And at that point, the sensor is going to wake up the Bluetooth Low Energy SoC, and the Bluetooth Low Energy SoC will notify that information to the smartphone.
Okay, these are really cool examples. But what about something else really impressive this board can do?
A lot of applications actually, especially in the industrial space, but also in the wearable space, they really require to know in a very accurate way the absolute position in space, rotational position in space. And so usually the state of the art of this technology is adopting sensor fusion for those sensors. Usually the challenge is that the sensor fusion works with a high performance microcontroller where you need a lot of MIPS and so on. What we achieved with this board is that we can run the sensor fusion Thanks to a very simple Cortex M0 microprocessor, so not a lot of MIPS available, but still we're able to achieve great capabilities and performances with the sensor fusion available on the board. So you're able then to really precisely map the rotational position of the board in space, and this might be of great interest in applications like robotics, for example.
Cool. What else?
So the other incredible part is actually that you can stream voice. Think about of a simple remote control. Nowadays, a lot of our remote controls for TV, they actually have voice control, right? So now you can use a microphone that is available on the BlueNRG tile, detect the voice, and send your voice over Bluetooth Low Energy so that the remote device, in this case the smartphone, is going to be able to play back your voice in real time. And this is a functionality that is not natively supported by Bluetooth Low Energy, but we were able actually to implement this in, again, a Cortex M0 SoC and is in a battery operated device. So that's another great functionality that is just an add-on, and you can use it for several other scenarios, like, for example, audio sync classifications. From the audio, you're able actually to understand what's going on around you. You are indoor, outdoor, or, for example, in a conference room like we are right now.
Okay, so after I collect and process all this data, what do I do next?
That's a super good question, right? Because now we got an incredible sensor with all these neat functionalities. We send all this information to the smartphone, and then what, right? Are we stuck on the smartphone? So no, what we did actually within the app, we have the possibility to connect the app to your favorite cloud providers. ST is partner of both Azure and AWS, and does a lot of work with IBM as well. So you do have the possibility to select your option through the app, either IBM or AWS or Azure, and connect to a remote cloud service, their remote cloud service, and post your data in your favorite dashboard. So you can see actually those data working in one of the three options. We also do provide a possibility to use a very simple MQTT, which is a standard protocol for cloud. So you can implement your own cloud service and use this custom MQTT service that doesn't need to be plugged into one of the cloud providers that we mentioned before. So it's very flexible.
Okay, so how does the tile achieve all of these features? What lets you get there?
When you look at the sensor, you see this little board that is only 25 millimeters wide, basically exactly the same size as the CR3032 battery, so very small. And when you look at the board by itself, you see sensors all over the place. Look at the picture over here. You see ranging sensor that allow you to measure distance with a high resolution up to 4 meters. So you can use this actually to measure distance. But you find also the inertial sensors, the accelerometer, the magnetometer, and the gyroscope that allow you basically to detect movement in a very precise way, but also rotational movement of the object as we showed before. Then you also see the microphone that allows you basically to talk to the board and send voice over Bluetooth Low Energy. You see also what we call the environmental sensors. There is a water-resistant pressure sensor that allows actually you to measure barometric pressure. And that's great help. For example, think about an application where you want to know on which store of a building you are, which floor of a building you are, right? So this will allow you basically to detect. Not only that, actually, the precision and the resolution of this pressure sensor allow you to understand if you're walking up or down the steps. So it goes up to a few centimeters of resolution. And then you look at the combo temperature and humidity sensor. This is really important because a lot of those applications, they need to be calibrated in the field. So you have wireless sensor node with all these sensors, right? You use the sensors in the field, but most of the time, the behavior of the sensor is really affected by the temperature around the sensor, but also the humidity around the sensor. So those sensors help you to really calibrate the inertial, for example, that you want to use. So you have a calibrated application. So there are fundamental blocks for the end application that you want to use. And then at the center of all this system, there is a Bluetooth Low Energy SoC, the BlueNRG-2. This device is basically a Cortex M0 Bluetooth Low Energy SoC, one of the lowest power consumption device in the market. That's why we're able actually to push this entire application to very low power consumption limits. And also it offers the processing power that is good enough to drive the sensors and run all these libraries.
So, Francesco, can you tell me a little bit more about the architecture of the tile?
Absolutely. It's a very simple architecture. If you look at this picture, for example, you see the BlueNRG-2, the BlueNRG SoC at the center of the architecture, and the device is connected just using I2C to all the sensors. So all the sensors actually, they are connected to the I2C. And then you see the microphone that has a dedicated port. So it's connected through a dedicated port. And then you see the top portion of this scheme, you see the antenna matching, which brings me also to another important point. The boards has been FCC certified already. So the design that we have put together is a really robust design that is available to everybody that wants to use it. So we make available the Gerber files, the BOM, the schematic. And again, being FCC certified, that's another value of this platform. Developers can just copy the design and basically they're almost 100% sure that that design can pass FCC certification if they follow those guidelines and design rules.
Okay, so tell me a little bit more about the BlueNRG. Why is it so great?
That's really the key element of this board, right? So we're able actually to run the BlueNRG-2 out of batteries together with the rest of the board. And the device by itself running out of a CR2032 battery can actually run for more than 3 years of lifetime. And this is definitely because of the lowest current consumption in sleep mode from this device. So it can go down to 0.9 microamp when connected using Bluetooth Low Energy. But also, if you, or for example, if you have the board not connected to a smartphone, this can go even farther down to 500 nanoamps. So this is really an incredible number for those type of radios. That's why we get this great current consumption. But besides that, the device has a flash that can go up to 256K with 24K of RAM. And this RAM is always in full retention, which means basically that even when the device in its lowest current consumption mode, which is basically the standby with 500 nanoamps, the device is still in RAM retention. So it preserves all the data that are within the device and it can wake up fast. So you don't need to reset the device. Finally, of course, the device is a 5.0 Bluetooth certified device with a very optimized stack that only requires 70K of flash and 8K of RAM for the device. And of course, has all the encryption functionalities and privacy functionalities that are required by the 5.0 standard.
So you talked all about the features. Is there a summary you could give me with all the functionalities and software libraries as well?
Absolutely. So I have prepared for you one slide that is going to summarize everything. So you see on the right side, the device, the Bluetooth Low Energy board. And on the left side, you see all the libraries that we support. So you see, if we start from the top, you see all the calibration algorithms. Those are super important in order to make sure that all our sensors are working properly. So you see actually calibration for the magnetometer, calibration for the gyroscope, and from the accelerometer. You want to make sure that all the intrinsic effect of the sensors are removed before we start any acquisition. So those are in there. And then you see the position tracking library. We see basically what we call the Motion FX, our sensor fusion library, together with the tilt detection and the compass functionality. All these functionalities can be explored individually using the app, so you can have access to each of them and really play a little bit with the functionality, so you can get used with that. And then you see also some of the activity tracking features, libraries, again, embedded within the BlueNRG-2 system on chip. You can recognize, for example, if a person is biking or if a person is carrying, for example, the unit in this pocket. Or you can have gesture recognition, for example, a free fall of the board, or if you're waking up the board, just moving it. And there is even a pedometer that is actually embedded in there. So for example, if you wanna try later, if you wanna get actually the unit, put in your pocket and just walk, it's gonna tell you with an incredible precision how many steps actually you have taken here just taking a walk in the office. And finally, actually, there are other libraries a little bit more evolved to understand if you're, for example, running, if you're standing, if you're sitting, or if you're using the little board and bringing, like you will bring your phone next to your ear, same story, it will tell you exactly, recognize that type of movement. So those are all additional libraries that are available within the BlueNRG tile. And the message here is that they're designed to be low power, but also to be efficient from a code size perspective, because they're all actually working within a 256K of flash device. So that's amazing how many things we can put together in this little board.
Great. Tell me a little bit about the power consumption of this board.
Yes, this is really the key element, right? Because when we designed this board, we had power consumption in mind. So we wanted to have this board actually to run on a standard CR2032 battery, and we wanted to have a very long battery life. So what we did actually, we said, okay, let's consider the most popular use cases that you will use, and let's see what we can get in terms of battery life with that specific battery, right? And here is actually a result of what we got. It's a quick summary. So if you keep the board in standby, which basically means that the board is not doing anything, it's just waiting for something to happen. And this something to happen can be either you take the board and you wake up just moving it. So you get 25 microamps for the entire board. So that's current consumption of the entire board with all the sensors in sleep mode and the radio in standby mode. And in this case, as you can see, you get basically more than a year of battery life for the entire system. Now we're talking about the entire system. The second step is what we call the advertise with 250 milliseconds. Basically, that means that not only the board is actually processing all the information coming from the sensors, but is also letting the rest of the world knowing that it is there, the board is there. So if you get closer to a smartphone, the smartphone will be able actually to see the board because the board is advertising. And in this case, of course, you can connect to the smartphone. In this case, we go up to 170 microamps of total current consumption in this specific case, which bring the battery life to 54 days. So we're assuming in this specific case that the board is advertising all the time, right? While in the real case, what will happen is that the board will be in standby, so with the current consumption of 25 microamp, and then you're going to move it, and then you're going to get into the advertisement. So typical use case, you're going to always kind of duty cycle between the two functionalities. Then we consider a few cases where you're doing something with the board. Like, for example, you're notifying the battery consumption to the app. And so you get this short time to 25 milliamps. So, for example, if you're so curious that you want to know the battery life of the board all the time, your battery will last only 37 days. Pretty good. If you're so focused actually to look at the board at the app for all this time. And then, for example, if you just want to monitor, that's another important case, continuously, all the environmental sensors, the inertial sensors, specifically the accelerometer, and also control the LED. As you can see, the current consumption increased a little bit more because now we're continuously streaming data from the board to the smartphone. And so we go down to 30 days. Then if you want to add the sensor fusion, so now we're really getting this board really busy in doing something. So checking the rotational position continuously and sending all this data, a lot of data through the smartphone. Now we're getting to 1.4 milliamps, which, by the way, is still pretty good considering the activity that the board is doing. And now we're getting into 6.5 days if we run this continuously. Finally, if we use the microphone and we want to stream voice, this is actually the worst case scenario for Bluetooth Low Energy, because that's really when you're sending a lot of data. It's basically you're streaming your voice into the app, and we get up to 3.6 milliamps and 2.5 days of continuous streaming of your voice. Can you do that? And then finally, if we consider also the ranging sensor together with the rotational position, so let's say we want to not only understand the rotational position of the device, but also measure the distance of this device from a specific target using the ranging sensor. So in this case, we go up to 8 milliamp, and we only have a little bit more than 1 day of current battery consumption.
Okay, so what does this look like?
So if we want to have a pictorial description of this, that's basically, those are the measurements that we took out of the lab, right? So the numbers that I gave you before are not just theoretical numbers that we put in that spreadsheet, but really, this is what we did with our tests in the lab to make sure that we can bring something that is really value for our customers. So when you look into this, you will see some of the peak in here of current consumption. That is really when you use the ranging sensor, which is a sensor that actually requires more current to be driven. And then you see, if you, for example, go to the right side where you see the standby and the advertisement, you see the lower current consumption state for the system, where you go back to 25 microamps or 170 microamps for the unit. And so this really gives you an idea that those tests actually can be done, and the device is really low battery power.
Now, where do you see the blue tile being used?
When we designed this, we had industrial application in mind. And specifically, there are a few applications where nowadays we see that the device can be used. The first that come to my mind is predictive maintenance. For example, let's say that you have an electric motor and you want to actually understand if this motor is going to have problems, like, for example, vibrations or a thermal issue with the device. So the blue tile is the perfect device that can actually be put next to the motor or on top of the motor to monitor vibrations, for example, do some pre-processing like even FFT within the device, fast Fourier transform, in order to understand the frequency behavior of the motor and really understand which is the vibration that can create problem, for example, to the motor. We also had in mind other applications like factory control and maintenance planning, but also energy management for the device because of the sensors that are in there. And the reason actually why we believe this is also possible is that this unit can also be used with a Bluetooth low energy mesh, BlueNRG mesh. That's a new topology that came out almost 2 years ago from Bluetooth Low Energy Alliance. ST has been part of that group, the mesh group, since the beginning. And this allows basically to build a network of sensors. So now you can imagine 10 to 100 of those sensors that are spread in the building or in a factory floor, for example. And all these sensors are using each other to bridge the information so that you can extend the range of your network and the capability of each single sensor. This deliverable is something that is already available and we show to a lot of our shows. And we're actually bringing as a part of our SDK software development kit in a few months on the ST website as well. So that's really perfect for applications where you need actually to have multiple sensors in the same place, building automation, factory automation, and so on.
Okay, so can we dive into more detail on some of those sensors?
Yes, absolutely. Let's really understand how the sensors are helping us, right? So I want to start from the proximity sensor, our VL53L1X. This is actually, we brand it as time of flight, TOF sensor. And this device is capable actually to measure distance up to 4 meters and has a field of view of 27 degrees. So pretty narrow field of view that we can focus on a specific target in order to measure the distance. So the 4 meters are allowed really to use this device in industrial applications where you can, for example, check the distance of an object. One application that I can mention is room presence. For example, try to imagine if you put this sensor, really the old BlueNRG tile, on the top of the entrance of this room, the door of this room, and then the ranging sensor can actually detect if a person is coming in the room or not. But the great part of this sensor is that because of the technology that we use, this is not sensitive to change of light in the room. So it can work in the dark, it can work with a lot of light in the room and with several objects, just because of the technology that is built inside.
What about the inertial sensor?
So the inertial sensor is another key element in the system. We run the sensor fusion using this sensor that is basically a combo of an accelerometer and a magnetometer. And the greatest part of this sensor is the lowest current consumption device in the market when we talk about inertial sensors. Only 0.45 milliamp of power consumption for the device. And if we only use the accelerometer, because you can decide to use both of them or just one of them, you can actually go down to 0.05 milliamps of current consumption.
Okay, so what about the magnetometer?
So the magnetometer is really important again for our sensor fusion, but also to use the device as a compass. And as you can see from this slide, this field range is pretty large, plus minus 50 goes. And the data that we get is 6-bit data output. So it gives you basically a very high resolution for the device, but also the sensitivity of the device is very low, 1.5 milligauss per LSP.
Now let's look at the environmental side of this. What about the pressure sensor?
So the pressure sensor, as I mentioned before, it's a water-resistant device that we use for the application, our LPS22HH, and has an absolute accuracy of 0.5 HPA. Relative accuracy is even lower. Also, the RMS noise of this device is very low, and it embeds a temperature sensor that allows you actually to do a temperature compensation of the pressure. As you know, the pressure changes a lot with temperature, so you want to have actually that part. So because of the absolute accuracy and relative accuracy of the device, you can actually do incredible things, as we mentioned before, as recognizing a step, if you, for example, working up and down the steps.
But pressure isn't the only part of the environment you'll have to worry about, right?
Correct. Actually, the humidity, especially in an industrial environment, humidity and temperature are always there, right? So we mentioned before the temperature sensor within the pressure sensor. That's enough actually to calibrate the pressure sensor. In terms of accuracy, that sensor is not enough for the entire application. That's why actually we decided to put within the unit humidity and temperature sensors with the right level of accuracy, in order to make sure that you can calibrate the entire application and work even in a harsh environment without any problem. So when you look at the humidity sensors, this has a range that goes from 0 to 100%. The supply voltage is also very large, from 1.7 to 3.6 volts, so very good for battery-operated applications. And when we look at the accuracy for the humidity device, a humidity sensor, 3.5%. Temperature accuracy plus or minus 0.5 Celsius degree for the device. Also, the other part, look at the current consumption, very low, 2 microamps. So all the sensors that we have been selected for this unit are really the lower current consumption for their category.
So you said before that I can talk to the board. Does it use a microphone? And what's good about your microphone?
So yes, ST is also present with a very huge microphone portfolio. And where really the added value of those portfolio is that the THD, so really the audio fidelity, is pretty flat overall the entire frequency range. So if you look, for example, at the chart here below, you will see a comparison with our competitors, and you see actually how flat it is, right? So this really allows the microphone to be used in a huge variety of applications, and the voice is the one that we showed previously.
Excellent. Well, I'm going to click that link right there and go to a Mouser.com page for more information. But thank you so much for joining me, Francesco. This was super cool.
That was really great, actually, having this opportunity to tell a lot about the BlueNRG tile. Thanks a lot.
And before we go, you didn't forget to click that link, did you? There you can find even more information about the STMicroelectronics BlueNRG-2 IoT Sensors Development Kit. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, it's right across the top. Or head on over to YouTube. Keyword